Okay, cool. So if you want to follow along, obviously Wi-Fi and Chrome, please, and then we're good to go. If you would join me on meetup.msb.com. Of the Wi-Fi. Yeah, I can maybe write it here. Like I don't know if this works. Wi-Fi ANRFBXNCD7. This seems good. Are we good? If anybody's not ready to progress, can you let me know? Cool. So, meetup.msb.com. So, you will see a registration screen. It's all normal sign up or just create a username, password. We won't bug you. And then you should be able to see the screen. So if anybody is not here, let me know. Otherwise, we're going to the fun part. So this button for you will be green. It will say start. Just please click it. And we should be here. So this is, let me see if I can do the full screen thing. This is Magic Sandbox. So if you're at this stage, you have, oh, this is loud. You have your own Kubernetes cluster running now. You will see what I think makes us pretty cool. On this left side, we will be showing some content, and this is where we will be doing the exercises. And this right part is a live representation of your system. So everything you're doing on the cluster will be visible here, and you'll be able to play around with it and expect it. So the workshop that we are doing now is, it sounds scary, Zero Downtime Deployments Workshop. What I found is that it's good if it's a bit more complicated, because then you can fit things in your head much better, because there's a goal to which we're working, instead of you just running basic commands and doing a hello world example. I think you'll be able to follow along, but let's go. So to progress, it's always the green button to progress forward. Sometimes it will say check, sometimes next, but let's go and click the green button. And you should be coming into what we call task mode. So let me just increase things a bit here. If you want to, there are buttons here to slide it left and right if you want to expand or contract or do something. So here you can see your the task that you should be running currently. So let's open up the editor and see what we are doing currently. So what we will be doing now is using the kubectl, which is the binary that you are using to interact with your Kubernetes API server. It's already been configured to target it correctly. What we will be doing now is the apply command, which will basically tell the API server, it will send this YAML file to the correct endpoint and say, run this for me. This is my intent. So let's see what happens in this scenario. So we will be running kubectl apply f, which means file, pod.yaml, so this file that you have on your file system. And as you run it, you can see it appearing here. So this is, for some of you, maybe the first pod that you have been, that you've deployed. So if you hover over these green kind of check marks, you can see the actual events and what Kubernetes has done to get to this stage. So you can see started container, pulling image, busybox, successfully pulled and deployed your thing. So what this does is just does an echo hello Kubernetes and then sleeps for 3,600 seconds. So yeah, we have our first pod. Let's see how to interact with it in a basic way. kubectl logs and then my app. And this my app, you'll see that it is the name of the actual pod, right? So you can see my app here. And then you see hello Kubernetes. So this is the actual thing that was echoed inside of Kubernetes. So this is a quick way to see what's been happening on the standard output of your running containers. So this is just a short exercise. If somebody is not following along, please let me know. To get you interacting with Kubernetes, we'll get into more fun parts here. And just to get you familiar with the MSB interface, so obviously file editor, console, the live representation, and this visualization part is actually pretty interactive. So if you were to click on one of the objects, you will see a lot of things about it. So if you go to the YAML part of it, you can see that it's basically the YAML that you sent it, but it has a lot of defaults that Kubernetes has added to it. And if you want to play around with it later on your own time, the cool part is if you hover over any field, you will actually see the description of it and what is happening to it. So this is we've just deployed our pod, name my app. It's running the BusyBox, very scaled down Linux distribution. And this is what Kubernetes actually does for you. All these things are done by magic if you do not specify it. You can see its host IP, you can see pod IP, the status of containers, and a lot of details. So maybe let's close it. So I hope you're familiar with the interface and how you interact with MSB and your Kubernetes cluster. And let's delete the pod to clean up the space a bit. So you're running kubectl delete pod my app to delete the pod. It will take a few seconds, but you should be able to see a new event saying stopping container, my app container. It is one of these things that Kubernetes will do for you, basically a kind of graceful termination. The pod is gone, and we can continue. So we already went through the deployments a bit. This is a standard description of what a deployment is. So if you remember, it is an object that shows intent that you want a certain number of replicas of your pods running inside of a system. It's managed by the deployments controller, and it handles all the magic for you. So we already went through it, but maybe if you want to quickly go through this example. So this is, you can see things are highlighted as you're going through them. It's a deployment file. The deployment is called MSB Web. It's saying I want 2 replicas. So this part, the template part here, is the kind of copy of a pod specification, right? So this is what the pod will be managing. It's running an image called Nigel Poulton MSB Hello, and it's listening on the port 8080. So here also, if you're interested in some fields, you can highlight, you can hover and see the details of it. But let's get to the fun part. Yeah, we talked about this a bit. So let's run a few commands that you see it's an actual Kubernetes cluster running. So if you run kubectl get nodes, you'll see that you have a 3-node cluster running, master and 2 worker nodes. If you run kubectl cluster info, you can see where your API service is running, where your kubedns is running. So yeah, it's a standard Kubernetes cluster that you're now playing around with. So during these examples, we'll be using 2 Docker images that we've built specifically for this type of workshop. They're just very small Go servers that are returning simple strings, but they are behaving a bit differently. So one is a normal server that will immediately just start listening on a socket and return a basic HTTP response based on a pod it's running. And then the other one does the same thing, but waits for 10 or so seconds before starting, before serving traffic. And the purpose of this demo is to show you that this delayed server is a standard situation that we see when we're deploying applications. So if you think how a supervisor or something sees your system, if you're running a process, from a supervisor perspective, it's running, but it's not doing anything useful. It may be setting up still, it may be fetching things, and it's not serving anything on a port. And this is the useful part that we are interested in. And this is a common example, and then we'll see how messy it can get, and then we will use a Kubernetes mechanism to fix this situation. So let's go and create our first deployment. So if you are going here into the task mode, we will be working for now with this file called deployment-simple.yaml. Maybe if we go quickly through it, what will happen? So it's a deployment named simple. What it will do is run the simple environment server object image that we have pre-configured. It will return a basic response. And please keep in mind that we are running version 1.0 because we will be playing around with it a bit later. So let's run the command. Apply f deployment simple. So what will happen now is we will send this deployment object intent to the API server. It will be recognized by the deployments controller, and it will do a certain set of actions that will, in the end, have our pod running in the system. And if you run this command, you should see something like this. So here we have our deployment object. You can also inspect it if you want, going through its YAML, seeing all the fields that is there. But one thing that I wasn't talking about is this intermediate object. So you can see there's a deployment. There is a replica set in between it, and then here is finally our pod that's running there. This replica set is a controller unto its own. Technically, it is ensuring that there is enough pods running, but how a useful way to think about these replica sets is that it is one version in the history of your deployment that's running. So you'll see very soon what will happen as we are deploying new versions of our software and how these replica set objects will be used to keep history of our objects. So if we are at this stage, let's click check, let's proceed forward. So what we have done now is there's a pod running, and let's actually deploy a service to expose this pod. So kubectl apply f service. So you can see that the service is being created here. I don't know if how well it will work because this is a type of load balancer. So what this type does is actually the type that contacts Google and gives you the IP. Sometimes we have problems if like 50 people do it at the same time, but let's see. So if we think of what's happening currently, so I'm going to open up this pod just to see its details. If we remember what a service does is it routes traffic to all the pods that are matching its selector. In our case, the selector is app simple, right? And if we inspect this pod that we've just deployed, it has a label called app simple, which means it will be targeted by the service and the traffic will be routed to it. So let's maybe check what's happening. So the container running on the pod itself is, you can see it here, it has a port 8888, but what we've done with this service is we said we want you to listen on port 80, so the internal IP that it is assigned is port 80, and route all the traffic to port 8888. So the simple way to test if things are working properly is just to curl it, right? So once you create a service, it basically becomes a cluster-wide available host name, let's say, that you can use. So if we were, So if we were to curl the simple, just curl simple, the name of the service, we see the response of the pod, and it's an actual HTTP request that we've sent. So what happened is we've sent an HTTP request to the service, and it routed the traffic to this pod. One thing that you can do in MSB to quickly check if things are working is if you click on this port of the service, it will send an actual request. So you can play around with it and see if things are being routed correctly. What I want to check, I'm just going to get the info of this service to see if I manage to get an IP. Yeah, we got something called an external IP. So just to show you, if I copy this, oh, this is not good. So I'm going to go out of full screen, and to show you that it's a real cluster, I'm just going to go to this IP, and you can see that probably you also, many of you got it properly. For some, it might take a few minutes. But this is a nice example of this messiness that Kubernetes takes for you. So what we care about is that we want a load balancer service, and if it's set up correctly, we don't care if it's some vSphere provisioner, if it's GKE, if it's AWS. What it will ensure, if it's configured properly, that we get an externally available IP. So all of you, if you do kubectl get svc simple, you will get, if Google has been kind enough for you, you should be able to get something called an external IP, otherwise it's pending. So, did anybody get a proper IP? Yeah. A few of you did. So it might take up to 5 minutes because, you know. Sorry? You don't need it for this lesson. I just wanted to show, first of all, that we are a real production cluster, but second off, it's the load balancer type is a nice way to show. You just tell Kubernetes I want an IP, and then you don't care where it's running if it's configured properly, right?
How have you managed to expose it to
Yeah, so when you do this, an actual Google Cloud load balancer gets created, and all the traffic going to the load balancer to the actual will get routed to the service internally.
Taken care by GKE.
Yeah. But the point of Kubernetes is that it has a lot of these connectors to a lot of these providers, right? So ideally, I would just take this application and run it on another provider, and I wouldn't care what's behind there. All I want is an IP, right? So more examples of these are persistent volumes, things like that. You would just say, I want a persistent volume of 100 gigabyte, and then if your Kubernetes cluster is configured properly, you would get it, right? The point of the Kubernetes is that it becomes this nice abstraction layer that you think in its terms. So when you're thinking about your applications, you're thinking in terms of Kubernetes objects and not vSphere mechanisms or something like that, right? So the current state, we have a deployment with one pod running and one service running that's routing traffic to it. So let's have a bit more fun with it. So as I said, one of the things that the deployments do for you is to allow you to scale things. So let's scale this deployment. Let's say kubectl scale deploy simple replicas 3. Don't do 300 or something. You will break the cluster, please. But so this is the kind of magic of Kubernetes, that suddenly you have three pods running. One of the things, let's say, that you can do is hook up something called a horizontal pod autoscaler that will scale these pods up and down based on the metrics of your cluster. So if you say the CPU utilization of these nodes is 50% or something, or of these pods, then that means the load is high, scale it up, then scale it down. It works pretty nicely. The thing to keep in mind, and I return to that, all the traffic should be going through this service, and here you can see now that it's actually routing traffic to 3 pods. So now, if we're doing the curl through this service, curl simple, if we do several of them, you can see that it's actually different responses are coming in, because what these pods are doing are just returning the name of their own pod. So you can see that the traffic is being round robin through these pods, right? So even if I were to go to the external IP, if I keep refreshing, no, it doesn't work here because my browser keeps a persistent connection. But if you were to click here several times, you should get a different response every time, right? And the key part of this exercise was to show you we've just scaled the number of pods through the deployment controller, and the service picked up on it, and it's just routing traffic to them. So it's a nice way to let your system breathe up and down.
Can we see on the right side which pod is it?
Oh, yeah. um, yeah. I mean, you can see here by the name, right? So yeah, what we've been building now is this thing called a traffic capture. So all the traffic is actually being served to the front end. We just didn't build the visualization properly yet. Basically, pretty soon you'll be able to see your ingresses, services, endpoints, and the traffic going through the system, which is then useful for things like blue-green deployments, things like that, that you understand what's happening. So the mechanisms are there, we just didn't build it yet properly. But yeah, it's a very requested feature. Cool, let's proceed. So now we will do something called a rolling update. So imagine we've been working with the version 1.0, new version came out, and we would like to change it, right? So let's open the deployment simple, maybe it's not specified correctly. So we will be working now in the deployment simple YAML file again. And you can see the image specified is Magic Sandbox Simple LAN Server 1.0. So let's change it to 2.0, and it's important that you click the save button here, right, the blue one. So what we've done now is, let's say our Steam has been working, images have been pushed to the registry, it's ready to be deployed, and we would like the new version of the software deployed there. So all we have to do is change the configuration file, so it's all declarative configuration. We just say what we want and then let Kubernetes deal with it. So we've changed it to 2.0, you saved it, I hope, and let's run kubectl apply f deployment simple again and see what happens. Okay, cool. So this is what's happening now. As you can see, this is the part about history that I've been talking about. You can see that the old replica set is shutting down all the pods inside of it. A new replica set has been created, and now it is running 3 different pods. So what this allows you to do is constantly push new versions and say the strategy that how you would like them to be deployed. In this case, we don't have to go into too much details into this, but we told to this deployment that at any point we have to have max unavailable 0, which means if we specified we want 3 pods running, there always have to be 3 pods running, and something called max surge, which means how many new pods it can create at a certain time. So if this was 3, it would just create 3 new pods at the same time. So this allows you to either have very quick rollouts or just slowly introduce one by one if you see things are going well. The concepts of rolling updates are usually they would be kind of weird to explain because you have to talk about this in this jargon. But I think this is why MSB is cool, because suddenly you can see exactly what's happening and people usually realize, okay, now I understand, it's actually pretty simple, right? So a new replica set has been created with 3 new pods. And if you inspect them, you can see, where is the image? Yeah, it's actually running the 2.0 version of the image, right? So we have deployed new software basically to it now, and all the traffic is being routed correctly through these 3 new pods. Okay, so do you more or less understand what's been happening now? Because now we'll be going into this kind of messy scenario. I'm gonna assume this is a yes. Okay, let's delete this. Let's do kubectl delete deploy all to kind of clear up the screen, and we will be working with a new, let's deploy the service that we've created, kubectl. So, yeah. Mm-hmm. Yeah, so the question was, what is the point of having the replica set there at all? So, okay, let me show you this now. I'm just going to do a quick example now. You don't have to follow along with this. but let me just run kubectl. Please don't follow along, just have a look. Run nginx, image nginx, replicas 2. So now I'm just creating a random nginx deployment, and it started 2 nginx pods. It's all good. I'm just gonna edit it directly. Let's say I don't want nginx running, I want Redis for some reason, I don't know. It doesn't matter, I'm just triggering something to do an update. So the standard thing happens, a new replica set is being created, new pods are created. Now this is running Redis, not nginx anymore. We realized that we've been stupid. We're not even using the same ports anymore. We just made a huge mistake. So this is the point of the replica set. So what you're able to do is do kubectl rollout undo deploy nginx. So suddenly we're saying, oh, we made a mistake, and we are shutting down the new one and restoring the older version of the software, right? And this is one of the key parts of a deployment, that it allows you to have this history of what has happened in the system. And this is not taking like any space. It's not like there's pods running in the background. All of this is just a configuration file that says, this was my previous configuration. It takes 1 kilobyte, and you usually don't have to worry about it too much. You can specify max history and things like that. But the purpose of this is this kind of history of your deployments of your app that's been managed, right? You can roll out, you can say kubectl rollout to version 2, 3, 4, it doesn't matter.
How can we see the story?
Kubectl rollout history, I think. No. Yeah. Oh, maybe, yeah. So you can see we didn't do something called a record, but usually you see a course that has been changed. But obviously in a production system, this would be a much, it wouldn't be a dude messing around and running stuff. But yeah, and also most of the time in a production system, you shouldn't be doing this manually at all. It should be triggered by a CI/CD system, right? So you would have a nice set of YAML files in your Git, you would modify it, push it, CI/CD system would apply it. You wouldn't touch kubectl in a nice system. But if necessary, you can always do kubectl scale, deploy, nginx. It happens, if traffic is going up, something's not happening, you can always intervene into the system. It's just not the best scenario, obviously. Okay, I'm going to delete this. I think we should be I should be in the same state as you are right now. So now we're gonna deal with the messy scenario. We can go into task mode immediately, and I'll try to explain what's happening. So we will be using the deployment delayed.yaml file this time. So as I said, what this process will do is basically the same thing as before. The process will run, but there's a time sleep for 10 seconds, literally a command that will just sleep. And this is the purpose of this is to simulate that the process is running, whatever is managing the process sees the process is running, it just doesn't know if it's doing anything useful or not. For us, useful usually means serving traffic on a socket, right? So let's apply this. Deployment delayed. And yeah, you should see a familiar scenario. The container is running. At this point, it's not serving traffic. We can't see it yet. We'll see it very soon. It's running on port 8888. Everything is very similar to what has happened before. So right now, we have to create a service. I just wanted to show you that you can imperatively do stuff in Kubernetes. It's not advised, but you can. So kubectl has a command called expose, which will create a service that will expose these 3 pods. So let's run this kubectl expose. So this is done kind of magically for you. New service is being created. It's called exactly the same as the deployment. It's routing traffic to these 3 pods. We can check it if we are. Yeah, one thing that's happening here is a bit of a different mechanism, but here you can see directly how it's taking the name of the pod that it's running and returning it as an environment variable. So it doesn't matter, but the point is, if you're doing several curls or if you're doing these clicking things, you should see different responses, right? As the things are being round-robined or semi-random through your pods. So even if we do a curl, delayed, right? Because the name changed. Oh, this is not correct. Currently, we didn't tell it which port to run on, so we have to use the port. We have to specify the port ourselves. So port 8888, right? So this is what the pods are returning, and you can see it's changing as it's being routed to different pods. So now we will do the tricky part. So we will now do the same thing. We will change in the deployment delayed. We will be running version 2.0. It's actually the same software running. Please don't apply yet. So if you've changed the image to version 2.0, saved it, let's get ready to run it. kubectl apply deployment delayed, and let's talk what will happen right now. We will trigger the standard rolling update. A new replica set will be created, and new pods will start to be created. They will be running, they will not be doing anything useful. So what we will be doing is we'll be clicking this port, right? And we will see what's happening. Basically, what will happen is our requests will start failing because while the pods are running, they're stuck on the time sleep command and not serving requests properly. So, okay, let's go. Rolling update, and if you click this, okay, you see error trying to reach service, connection refused. Connection refused. So this is obviously a very not good situation for us. You're a bank. If you if things don't work for 10 seconds every time you deploy stuff, it's a very not good scenario. So here we see the situation kind of normalized, and we are now returning requests properly. And this, what I want to show you is that the process is running. So Kubernetes cannot know by itself, is it doing something useful? The process is running, and from its perspective, things are good. Obviously, from our perspective, this is not a good scenario. Every time we change something, for 10 seconds, most of our requests will not work. So I'm using this mechanism to show you one of the kind of magic things of Kubernetes is a lot of these small mechanisms that each of these objects allow you to kind of configure how things work. So in this scenario, we will be talking about something called a readiness probe. So the situation is the same as before. Inside of a deployment, we are saying the standard server is running, it's all good, ports are here, but we are adding this part, something called a readiness probe. So the 2 default probes of Kubernetes are readiness and liveness probes. What a readiness probe does, in this case, it's a HTTP GET kind of readiness probe. So what it will do is wait for 5 seconds, defined by initial delay seconds, and then every 5 seconds, it will try to do a GET request on this route, on path, root port 8888. And what this will do is, it will not be enough that the process is running. This readiness probe has to be successful for the container to be considered in a running state. So what this will do is, in a rolling update, it will go much slower because it will wait for the processes to actually be ready, and none of our requests should fail. So let's go into task mode. Let's, again, kubectl, just to clear up the screen a bit, delete, deploy, all. So let's do now. I will be typing it out. If anybody has some issues, please let me know. But we will be adding a readiness probe to this deployment. So it's important now to think about YAML and its structure. So a readiness probe is defined on a container level. So you have to go inside of spec, template, spec containers, and then edit this container itself. If anybody has issues, please let me know. There's also a full solution there. So let's do this. So we will add a readiness probe on the container level, right? Of a type HTTP GET, path, root, port 8888, basically the port that container has an open port on. And then these few configurations that we want to add, initial delay, seconds, 5 or 3. So it's how long to wait before doing a first request. Period, seconds is 5. So every 5 seconds poll for it, and success threshold 1, which means as soon as one request is successful, consider it being in a good situation. So let's see how this goes. One more thing we can do. Maybe let's change this back to version 1.0, okay? The image. Is that okay? So let's see what will happen now. If we were edited it correctly, let's run kubectl apply f deployment delayed YAML. So the standard scenario, you can see the pods are grayed out. They're not ready yet. They're not in a ready state. And you will see now, it will say readiness probe has failed. So it has been 5 seconds, HTTP request has been sent. It's not a good scenario, no response. And suddenly you can see them coming alive after a certain period. So it took a lot longer for it to happen because the readiness probe was checking if the system is in a correct state. So if we are running the request now through the system, it's all good. The requests are being serviced correctly. Okay, so this is the kind of problem. So basically what this is a live representation of the events that Kubernetes sends to you, and unfortunately Kubernetes doesn't send we're in a good state. So you just see the last event that's there. This is why we have this kind of grayed out and full color view, so you know when it's ready or not. We were thinking of adding it there, but then it's actually not a real event, so it's kind of cheating, you know. But it's a bit stupid that it says readiness probe failed, but technically that was the last event that has been emitted by Kubernetes. So let's do a quick scale just to see what happens. kubectl scale deploy. So the purpose of this is to show you, as soon as we scale it, we will be running the requests, and had this readiness probe not been there, 1/4 of the requests would be failing. But now you can see that they are not in a ready state, and the pod just being created, so none of the requests are failing until a readiness probe decides that it's ready. And suddenly at this point you can see, this is actually the request, that traffic is being serviced, routed to this pod, and it's all good. You can see the pod, the service is actually seeing 4 active pods. So this is a very good scenario. This is a situation where we want to be in. This is a readiness probe. There's also something called a liveness probe that can keep pinging things to see if things are okay. You don't only have to send HTTP requests, that there are commands that you can run. There's pretty advanced mechanisms around it. And then, just ignore this. Let's do the same thing. Let's change the version to the name, the image to version 2.0 again. And we will be triggering our last rolling update and then trying to see what will happen. So yeah, let's save it. So if you remember, I hope you understand by now what will happen. We will be triggering a new version, a new rolling update, a new replica set will be created, pods will start to be created. Last time we did it without a readiness probe, we had a lot of failed requests. Let's see what happens now. Okay, you can see it being created, but it's still in this grayed out state, and none of our requests are failing actually, because they are not in a ready state. And suddenly you can see how it nicely transitioned into a new version with no requests failing. One thing that you may have noticed now, that the transition has been a bit faster because we've had a different configuration of a rolling update. So we said max surge 2, so create 2 new versions, keep 1 unavailable, so it was a bit more aggressive rollout. So if you followed along, thank you very much. I hope you understand, like, the purpose of this was to introduce you to some Kubernetes mechanisms in a bit more advanced way. I hope you were able to follow along, but what I want you to take away from this is everything's an object. Everything is useful for you, but there's a lot of, the worst thing that you can do is learn just a bit of Kubernetes and then continue doing what you were doing before, because there's a lot of these advanced mechanisms out there that will make your life a lot simpler. So just with a few config changes, we managed to have this zero downtime rolling update. Thank you. Let's see, do I have any questions?
Any questions?
Yes.
Can we try it even later?
Yeah, so let me just show you what MSB, so the question is, can we try later? We are a learning platform. I will show you now our kind of self-serve portion of the platform. This was like a small workshop that we do. We like to do these whole day full workshops where we actually build proper applications using MSB and doing a proper CI/CD system, things like that. If you're interested, just send us an email, let us know. We can arrange something. We really like doing that. Emails mislav@msb or jord@msb.com. So we've been doing now the meetup.msb.com part, but what I would be really happy if you went to, you can just go directly through MSB, or just go to msb.com or go to learn.msb.com. So what is here is our kind of self-paced learning platform. So the same interface, is just that there is a lot more content out there. It's being developed by, a few of you have told me, you know, Nigel Poulton. He wrote the Kubernetes book. And it's a much more self-paced environment where you are going through, let's say in this case, deployment themselves. You're fixing up YAMLs, you're debugging systems, you're doing things. So there is this whole learn.msb.com, and just mess around with it as much as you want. A lot of it is free. You will always get a cluster, and yeah, have fun.
Can you pre-install into terminal some tools like Vim, for example, because I see it's not available?
Yeah, we have to do it better. So there's VI, but not Vim. Yeah, so we will polish it up. There's also, let me just. We actually have Helm installed, so you can do Helm install Redis latest, I think. Maybe I'm not correct. You can play around with Helm. One of the cool parts you can do is actually, if you look at the kube system namespace, you can see everything that's running inside of Kubernetes actually, and how it's all hooked up. So yeah, play around with it. Suggestions like that, just talk to us on Slack or send us an email or on Twitter or whatever, and we're happy to talk to you. Yeah, thank you, Eddie, for hosting us. It's been great.
Yeah,
This has been the nicest place we've been so far.
Mislav, Jort, Johan, many thanks for coming here, showing this wonderful platform. Gonna play with it, definitely. And I'll give him again a big applause. And we have now some drinks and some snacks if you want to join us.